Perfect. So welcome to the Antrea community meeting. Today is Tuesday, July the 14th, unless you are in the US, in which case it's still Monday, July the 13th. So for today, we have two topics in the agenda. Srikar and you are proposing a demo of the flow exporter feature. On the other end, we have Jechang and Wenning that would like to discuss the IPv6 proposal. Overall, we have allocated about at least 20 minutes for the flow exporter demo and roughly 40 minutes for the IPv6 discussion. This means that these two topics we are going to fill up the full agenda for today. So before we start the meeting, I would like to know if there is any other topic that the community would like to discuss today. Waiting 5 more seconds. All right, so if everybody agrees, my proposal is to start with the flow exporter demo from Zerikar, which should take roughly 20 minutes, and then move to the IPv6 discussion. This will allow us to complete for sure the flow exporter demo, and at least to kickstart the conversation on IPv6, which we can then, should we not be able to finish the discussion on IPv6, we can either continue it either on Slack or perhaps, have a second design review in the next community meeting. If that sounds
Hi,
good
Salvatore.
to you.
A request, like you had just started running traffic. I just want to ask her if you are ready to demo. We are thinking we'll go after IPv6.
Okay.
Yeah, if
Yeah,
that is okay.
yeah, it's okay to demo. Just use the last 5 minutes record.
Okay,
Okay.
that
All
works.
right, then let's go with it. Yeah. Sure.
Okay, works for me. So let's start with IPv6 discussion, and I see that Wenning and Zhaochang are on the call. So I know that you have a document to share and a lot of topics to discuss. So perhaps we can get started with that. Let's go ahead.
Hello everyone. So I will share my screen with Ipv6 stack design. May I start now? Hello?
Sure, please.
Yeah, go ahead.
Okay. Hello everybody. Thanks for attending the discussion for IPv4 and IPv6 dual stack discussion. First, from the upstream Kubernetes community requirements for the IPv4 and IPv6 dual stack, we got some requirements. First is if the cluster is planned to support the dual stack, there should be dual stack port networking. That means for each port, it might have a single IPv4 and an IPv6 address. And second, the cluster should support IPv4 and IPv6 for services. That means although we have IPv4 or IPv6 addresses for the service, but for each service, it only has a single address family, which means for service address, it will be either an IPv4 or IPv6. And the third requirement is for port of cluster egress routing. If the cluster is enabled with IPv6, the port should access an external address with IPv6 interfaces. Except for the 3 requirements from the upstreaming, we have another 2 requirements for Antrea. First is for the network policy. as we all know that we are using the pod in network policy and IP blocks for the network policy rules. If the cluster is enabled with IPv6, we should support IPv6 addresses in the network policy rules. And the last one should be for truth flow. As we may know that we are using a packet out message to trace the open flow entries for the Antrea functions. So if we have enabled IPv6 for the cluster, we might to be able to generate IPv6 packets to trace the flow entries. All about 5 entries are for the requirements. Then if we want to enable the IPv4 and IPv6 build stack, some prerequisites are needed for the cluster configuration. First, we need to enable the feature gates with the IPv6 build stack. And the second one is for the cluster CIDR configuration. There should be an IPv4 CIDR and IPv6 CIDR. And the third one is for the cluster, the service cluster configuration. We could configure an IPv4 and IPv6 CIDR. And the last one is for the node configuration. If we want to support IPv6, the node should be configured with both IPv4 and IPv6 addresses. And by default, if we have already configured the cluster CIDR for the cluster, the pod subnet for each node is allocated to either 24 bits for the IPv4 subnet or 64 bits mask for the IPv6 subnet. Then we come to the design for Antrea to support IPv6.
So when you have a quick question here.
Okay, yeah.
So do we support IPv6 only node IP config, or we support both IPv4 and IPv6?
For design, we want to support the dual stack, but I think if we have already supported the dual stack, we could deploy a cluster with only IPv6. It should be okay.
Okay. Okay.
Okay. Then we come to the detailed design for the dual stack. First is for the dual stack pod networking. To support the dual stack pod networking, some changes are needed for the Antrea agent. First, we need to read for the IPv4 and IPv6 subnet CIDRs from the node spec. And then we need to configure the pod CIDR to IPAM configuration. We will continue to use the host local IPAM plugin for IPv6. And then after the IPAM has been configured with both IPv4 and IPv6 addresses, it should be able to allocate a single address for each pod. I mean both IPv4 and IPv6 address from the IPAM driver. And the third one is we have to configure the IP addresses allocated from the IPAM driver to the container unique. Currently, Antrea only finds the IPv4 address from the IPAM results. But if we want to support the dual stack, we need to loop all IP addresses from the result, and each one we need to configure to be configured on the container unique. And the fourth step is Antrea agent needs to configure the local gateway with both IPv4 and IPv6 addresses. And after this configuration, Antrea agent has some changes on the open flow entries. First is for the IP safeguarding table. We need to support the IPv6 address Something I want to remind is that if we enable IPv6 on the interface, there should be a link local address and the global address configured on the interface for IPv6. I mean that there should be at least two IPv6 addresses configured on the interface. So for IP safeguarding, we need to support both two IPv6 addresses. For the link local address, the IPv6 interface will use it to send the multicast listener report message. So the OpenFlow entries should allow this kind of traffic to be forwarded to normal ports. And another way is that IPv6 might use the global address to communicate with other pod addresses. So we need also allow the packets using the global IPv6 address as the source address when the packet is leaving the pod. The second change for the OpenFlow entries is for the ARP. For broadcast is not supported in IPv6, so there will be no ARP traffic requirements for the IPv6. Instead, we need to support SAMPv6 NDP protocol to support the pod querying the MAC address for the destination. This is a substitute for the ARP responder. And the third way is for the routing table. We need also to use the global WMIC to respond to the peer gateway mic for each node. Another thing for the OpenFlow entries corresponding to the pod networking might be the tunnel configuration. I mean, if the node is configured with IPv6 address and it joined a cluster with IPv6 configuration, we might raise the node IP from the node spec with the result of an IPv6. Then we need to configure the tunnel destination IP address with the IPv6 address. To support IPv6 in tunnel, OS version should be larger than 2.6. This is a change for the OS requirements to the current implementation.
So when are you going to support low income mode too?
I think we should support no in-cap mode, but for no in-cap mode, I think we have to implement routings, right?
Yeah.
Yeah.
So sorry, just to confirm, it's also
Okay.
included in your plan, right? Low income mode.
I have no much details for the no in-cap mode, but there is an open issue about the IPv6 routing. Maybe. Oh, okay. Then I will continue.
I have one more question. Actually, I haven't looked at other things for the. I wonder, do you believe the load IPAM, I mean subnet per node, is a typical IPAM strategy for IPv6 too, or there are some other ways to IPAM for IPv6?
We have some investigation on host local. I mean the IPAM driver we are using currently. The IPAM driver is also supporting IPv6 IP allocation. So I don't think we need to change that IPAM.
I understood, but I just mean, does that is that other thing implementation, or we believe typically people do use subnet per node for IPv6 too?
Maybe we could have some more investigation on other IPAM plugins.
Okay, sure. Probably we can look into that.
Okay.
Yeah, yes, John, this is Salvatore. From what I've seen, I have not seen actually an implementation using methods like Slack or DHCPv6 to assign IP addresses. Honestly, I also have not seen any case of a global subnet, but it is also true that there are not many IPv6 implementations
I
out
see.
there. So, but
Got
the
it.
most important thing is that it seems that static IP addressing is still the preferred way for assigning IP addresses.
Okay, got it. And we assume that for the external traffic, people still do SNAT to the node IP.
That is the point that I believe that Wenning was going to discuss later. Is
I
that
see.
correct?
Yeah. It is one open issue. I need to have more thoughts from the community.
Got it. I will, probably I should just let you continue, and we can see you
Okay.
later.
For the second feature, Antrea needs to support for Ipv6 is the network policy. If we want to use Ipv6 address in network policy, I have thought two changes. First is for the control plane and Antrea agents. The control plane needs to identify both the Ipv4 and Ipv6 addresses binding to the corresponding port. And the second one is for the open flow entries. We need to support using the Ipv6 addresses in the conjunctive match flows. I think if we want to support Ipv6 address in network policy, there should be no changes in the controller. So all changes are focusing on the agent side.
I think just to make a note of for completeness, maybe we should also just make sure that the cluster scope network policies and the other CRDs are also covered under this scenario. There should not be much changes apart, because we share a lot of code with the network policy code.
Yeah.
But for completeness, we should make note of that. And also just a generic comment that there's a lot of validation that is being done with OpenAPI for fields which select IPv4 as a field. Maybe we need to take a look at all those validations and ensure that IPv6 is also allowed.
Okay. So you mean that we still need some investigation or verification on the controller side?
No, on the agent side, I don't think there should be any other change, but just as a note.
Okay. And the third features for Ipv6 should be about the services. To support Ipv6 services, we're still using the OVS net feature to take transition from service address to the backend port address. And the most changes should be about check the service IP address family. We need to enable an OVS access reg 3 to catch the selected backend port's IP address from the load balancer algorithms. For Ipv4, we are using the register 3 to catch an Ipv4 address, but for register, I mean the reg 3, reg 0 to reg 15, they have only 32 bits, so it is not long enough for an Ipv6 address. Hence, we have to enable the access reg. For each access reg, it has 128 bits for the catch. So we need to enable this one in the open flow entries. And another changes for the services is that we need to support using the Ipv6 addresses in the service matching or action fields. Then the last feature for Antrea is the trace flow. And the only changes is we need to support generate an IPv6 packet. Then, except for the features we need to implement on Antrea, I still have two open issues. Want to have some discussion with the community. First is, as we may know that the IPv6 address is long enough, so for most cases, SNET is not using in the IPv6 traffic, especially for the north and the south traffic. So I want to have some discussion about how to implement no SNET for IPv6 traffic, especially for the north and south traffic. If we don't use the SNET, I mean, first we might remove the IP tables configuration for the masquerade. Secondly, we need to have some routing configurations. But how to configure the routing might be a challenge for in-cap mode. Especially we have some already defined some routing configurations for the overlay configuration. For example, if we want to access the port subnet on another node, we need to routing the packets to the gateway first, and then using the OS pipeline to process the traffic. But then how to coordinate the north and south traffic when the packet is leaving OS to go to an external address?
So in my understanding, if you're saying we don't need SNET for north-south traffic, then what's the value to do in cap mode? I mean, even for in-node traffic, you just do cap.
Sorry, maybe I lost something. My network seems unstable. Hello?
Hello, could you hear me?
Yeah, clearly.
Yeah, I'm just wondering, since you talk about no SNET for in-cap mode, right?
Yeah.
But I'm wondering, if we do no SNET, that means the underlying network already know about the port IP. Then in that case, why we still do in-cap mode? And even for internal traffic, we can also do no in-cap, right?
You mean they don't need to support in-cap mode?
Yeah, just my question when I saw this point from you. Because I think we do in-cap just because we don't assume the underlying network understand our IP address, and then there's no connectivity between nodes for the port traffic directly. But if you're saying anyway underlying network, they understand the port IPv6 address, and there's no any value to do in-cap.
It is a good question.
But actually, I don't really know much about how other things implement IPv6. I'm not sure. Have you looked at other things as well?
I mean, IPv6 should be fairly independent of in-cap, right? It's kind of orthogonal discussion between IPv6 and in-cap, I guess.
Mm-hmm.
Good question.
By the way, when we do in-cap, we're doing using IPv4 to be the out header, right? I guess must be the case. Since for West and GLib, they are all IPv4 header. Okay.
If we implement in-cap mode, the channel is both okay for IPv4 or IPv6. OS supports both IPv6 over IPv4 and or IPv6 over IPv6.
For IPv6 over IPv6, it's what will be the tunnel protocol?
We need use the node IP address to encapsulate the tunnel. So if the node has joined the cluster with an IPv6 address, we might to read the IPv6 address from the node spec. So we have to use IPv6 for tunnels.
But I think for Western G-Leave, it's IPv4 only, right? No?
No.
Oh, really?
OS already supports IPv6 on over IPv6.
So it's IPv6 over IPv6 for the not Western or G-Leave, right? It will be a new tunnel
I
type.
think so. Yeah.
Oh, got it.
Yeah.
Got it.
When I make the design, I just think Antrea is assuming the encap mode is the default mode. So I didn't think of we could not support encap mode for IPv6.
No, I'm not saying that. I'm saying the case you want to do encap mode for the you also want to do no SNAT. For that one, I'm just wondering, do we need to support that or not?
Salvatore has suggested us that if we already support no encap for IPv6 for the north and the south traffic, we might no need to implement the next night for IPv6 north and south traffic from some requirements from VMware, some other BUs. So I think we should first have an agreement on whether we need to support SNAT for the north and the south traffic, and then we could continue the discussion about whether we should support the no encap in no SNAT in encap mode.
Let me probably, since the whole point of this discussion is that with IPv6, no SNAT topologies are way more common than SNAT topologies, which means that a solution with north-south SNAT will definitely work, but it's not probably what most users will be looking for. Let me try and put the problem under another perspective. Let's think only about IPv4. Now, with IPv4 in Antrea, are we able to fully support fully routed topologies? It was my impression that with in no encap mode, we could do that. Is that correct?
Not really. For low income mode, actually, we assume underlay network will do routing between nodes. Mm-hmm. That means some other solution will handle the routes. For example, maybe the Kubernetes cloud provider can populate routes to the underlay router, but Antrea doesn't really handle the routes.
Okay, I see. So let's say that at the moment we don't really have a solution in Antrea to implement no SNAT, fully routed topologies without SNAT, right? Perfect. So in light of this, in my opinion, our approach should be that for IPv6, we proceed with the same approach, meaning that we will do SNAT, even though, let's say, it's probably not the most common use case. And then we should start another activity for allowing fully routed topologies, which is, it's the main use case in IPv6, and it's probably a fairly important one for IPv4 as well. I don't know what is your feeling here.
Okay, I think if you're thinking that way, then I do agree. Probably it's a separate problem, and we need to support routing first.
So Jinjin, your point is we should support routing as the first step.
Actually, I'm still thinking of for low income mode. Of course, I mean, if later have a way to do routing, I mean, that means we can populate routes or entitled with physical router and can be a complete solution. For now, maybe we can still assume some other solution will do the physical router interaction for us, like like the Kubernetes cloud provider. I'm not sure the cloud provider can do IPv6 routes. I guess maybe some provider can do, like AWS or maybe a GCP provider can do that, but I didn't check that. And for the in-cab mode, I'm thinking maybe we don't do no SNet, we still do SNet.
Okay.
IPv6 too. Just my personal opinion, but actually I didn't really look into the IPv6 much. So.
No, that makes sense. And you have a good point about relying on the infrastructure provider for routing, because it's the usual thing, you know, that the responsibilities of Antrea are limited to the Kubernetes cluster itself. So when it comes with communicating with the infrastructure, which could be either by injecting static routes or announcing you know, subnet routes, I really don't know if this is something that we want to add to Antrea or not. Mm-hmm. Because it feels like we might end up adding code which is dependent on the infrastructure, and therefore adding opening a can of worms that we probably don't want to open. So you might have a good point that we might be able to support routed topologies as long as the underlying infrastructure provider allows us to do so. So, you know, it takes care of all the routing part. So that could be a good point, a good design principle for us too.
Right. For the starter, I think IPv6 is still different from IPv4, right? If we do, for example, if we do SLC, do you think we can solve this routing problems already?
What do you mean different? In which aspect do you mean it's different for IPv4?
In the case of SLC, I think we have a way to like the physical router know about our IP address, right? No? Based on my understanding, maybe I'm wrong.
I am not sure. I probably just don't understand your question. What do you mean that we have to let the physical router know about our IP address?
Oh, I thought for SLC, actually, the endpoint will be changing information with physical router to confirm the IP allocated by itself.
Oh, okay. That will be in the case of Slack. Yes, that's correct. That will be in the case of Slack allocation. In the Slack allocation, basically, yes, a router advertisement message from the infrastructure router, and then the station then auto configures its IP address, but then it sends a neighbor, and then that's pretty much auto configuration. There isn't in that case a feedback like you know, the station telling the router, hey, I have allocated this IP address. But if we use static IP allocation, the only changes in the protocols are supporting the neighbor discovery protocol, as already mentioned by Wenning, and then, you know, that other change for allowing spoof guard with IPv6 addresses by allowing also the link local address.
Got it. I'm just wondering, is that Slack or is a typical way people do IP allocation in IPv6 and enable?
If we talk about virtual machines, say generally stations, that is definitely the most common way, Slack. But for container solutions, and especially Kubernetes networking, I have not seen so far any IPv6 IPv6 IPAM leveraging Slack. From my experience, which anyway is fairly limited, everything is still static IP address allocation.
Got it. Okay, got it. Thank you.
Anyway, so I hate to say this, but we are using quite a bit of time. So perhaps this SNAT versus no SNAT discussion, something that we can probably continue on Slack, unless there is something else that you would like to mention on this one.
Yeah, that works for me.
The second open issue I want to discuss is about the nodal addresses. Antrea is using the node spec to pass node internal addresses, but there should be a single address for the internal address for each node in the spec. If we enable dual stack, a node should configure at least two IP addresses. One is an IPv4 and another is IPv6. But from the node spec, we might be able to retrieve only one address, so we might lose some information. This should be an issue from the upstream Kubernetes implementation. So we might have an issue created for the upstream first, and then for Antrea implementation, it is just a notification for the developers that we might lose something.
Sorry, I don't understand why this is an issue. Why is it an issue that the underlay and the overlay have a different address family?
I'm not sure if we need to use both addresses for the node IP, either the IPv4 and the IPv6 from node spec. I mean, because of the limitation from the upstream implementation, we might be able to retrieve only one address in the development. So I just mentioned it in the design doc.
Actually, that's probably like a shortcoming on my side, because I guess I don't know enough about dual stack. I need to look into it, because I don't see why supporting dual stack for pods means that each node now needs to have like one IPv4 address and one IPv6 address. That kind of like sounds a bit orthogonal to me, especially.
It's not required. No, it's indeed orthogonal. It's not required. The thing is with I mean that as a part of this design, we also Wenning also wanted to ensure that dual stack also worked for nodes, because I think, and maybe that we want to be able to create either V4 or V6 tunnels, right?
Yeah.
I mean tunnel endpoints. I'm talking about tunnel endpoints. But you're right that, you know, for dual stack containers, having also the node in dual stack mode is not required at all.
Okay, yeah, that makes more sense, because I'm like, if I'm building an overlay network, I don't really care that I mean, maybe it has an impact on the encapsulation.
No, you're right. Even for L checks, you know, if the containers is dual stack, then for the L check to work, the node can be either V4 or V6. As long as you have one IP to get into the container, it's fine.
Okay, so that's kind of like an orthogonal problem about also supporting dual stack for.
Mm-hmm. I will definitely not say this. Yeah, go ahead. Sorry, go ahead, Janjan.
Yeah, I'm just thinking if, for example, if node is IPv4 port IPv6, and then how could we node reach the port or port reach a node?
That is correct. That's indeed under the assumption that the pod is dual stack, then on the node we just need one IP address.
Okay.
Yeah.
Yeah, if the pod is dual stack, the node should be configured with both IPv4 and IPv6. And I think it should use the Ipv6 address to have the liveness check for the Ipv6 if it is targeting at the Ipv6 address.
But generally, in our case, the node would like use a gateway address, no?
No, I mean for the remote node.
Oh. Well, but you mean a remote node outside of the cluster?
No, remote inside the cluster. You're saying they should remote should always use IPv4. I missing about what you mean. Not just about port rich and node rich port, but it can also be node port to load rich node IP, right? Of course, I mean if the router side port is always still stacked, then can use either IPv4 or IPv6. Originally, I was thinking maybe port have only a IPv4 or IPv6 address.
I think the dual stack configuration is a global configuration. If we have configured the cluster with the dual stack, and each node in the cluster should be enabled dual stack.
You're saying that means even for node IP, it must have both IPv6 and IPv4.
Yeah, according to the Kubernetes requirement, pre-requirements, the node should configure with IPv6 address if the cluster has already enabled dual stack.
Okay. Then it's a little strange now. I agree. It's a little strange that in the node spec is only one IP.
We can't, if we might not be able to configure the cluster with only one IPv4 cider if already configured with dual stack. Then the feature might not work.
Okay.
The last thing I want to share is about the limitation. Since the OS on Windows doesn't support IPv6 in contract and IPv6 tunnel, IPv6 feature is not supported on Windows in the first phase. So we will not cover the Windows IPv6 for Antrea in this phase. That's all for my part.
Thanks, Wayne. And that was very good. Now, for IPv6, we should also discuss the CI pipeline. I am a bit concerned that there might not be enough time in today's meeting to include also the the flow exporter demo, but it will be a shame to leave the IPv6 discussion incomplete. So I will say let's try and complete the CI pipeline discussion perhaps in a few minutes to leave at least let's say 5 to 10 minutes for Srikar and you for the flow exporter demo. Please go ahead.
So, Wayne, could you stop sharing the screen?
Yeah. I have stopped.
Okay. So, can you see my screen now?
Yes.
Okay, thank you. Okay, so let's start the discussion for the Ipv6 Ci pipeline. So currently we have several jobs on like 3 platforms. First is the GitHub Actions. So it has its cluster set up with kind and on VMC. So these are the public CI jobs, so you can see the results of them. And also we have some jobs, most of them are Windows jobs. They are on the private CI. So basically we have 2 problems to solve. First is to set up the testbed with IPv6, and then is the IPv6 specific jobs. So first, let's talk about the testbed. As for the GitHub Actions jobs, I find a tutorial to introduce how to deploy Calico IPv6 with kind. So I think it won't be much trouble to set up with kind on our GitHub Actions. So it's easy. Then let's move on to the VMC. So basically, we have discussed with the TKG teams about how can we set up such the clusters. They mentioned that we may need to add the IPv6 side, including port and service, to our cluster templates. Also, there may be some other configures. But now here is the issue that the TKG team who is responsible for the CAPV, which we use to set up the testbed on VMC, they are not sure about if we can successfully deploy the IPv6 cluster on VMC. We are going to have a meeting with them to talk about its possibility next week, and we are going to maybe we are the first project for them to test it if it is possible, but we will see, and I will report the results in the repo. And if it is not possible, maybe we can have other cloud to host these public jobs. Yes, and for the private, those Windows jobs on in the private lab. So the issue is that this private lab does not support IPv6 currently. Our office network doesn't support it so far, but we have two solutions. First, we may ask the IT guys to try to give us some IPv6 either for our test bed. Also, we may have a simulation for we have simulation to make our testbed cluster to be in IPv6, and it's sending IPv6 traffic, but it is actually in an IPv4 environment. But this is not the best choice, since we want to have a really real IPv6 testbed. So this we will try to, maybe we can successfully set up a IPv6 environment, maybe asking IT for help. And then it's about the jobs. So as for GitHub Actions, I think we can do just like how we have done for like proxy. We can edit the test E2E kind of script, so we can run the IPv6, run the test with IPv6 when we want to do. And as for the Jenkins jobs, so with Jenkins Job Builder, basically it is the same with our current jobs. And maybe there's some small changes. First, maybe we will have some new IPv6 E2E tests, so we can have some modification on our testbed setup. It is possible. Then as for conference test, we are going to add the dual stack focus keyword to our conference test, and it should include some IPv6 related tests, but we also need to add port to node and node to port cases, which is not included in the dual stack test. It should be done by ourselves, maybe add some jobs, add some tests here. So after, we are going to verify if it works after the implementation of IPv6. Yes, this is basically the IPv6 Ci pipeline. Sabato. So if you want to continue.
Yes, thanks. Thanks very much for this introduction. And as time is flowing very fast, I think it's time to move to the Flow Exporter demo.
Hi, Salvatore. I think there are 8 more minutes. Is it okay if we take this up next time?
You surely believe you need more than 8 minutes? I mean, if everyone agrees, I will not mind, overflowing the meeting by a few minutes, unless people are busy, or especially for people in the US, unless you want to go to bed.
Yeah, I'm okay with it. Like I thought, last time we wanted to finish around 10 o'clock, right? That was the plan. That's
Yeah,
why
that's
I
right.
don't want to
I
push. Yeah, yeah.
Okay, so you prefer doing the demo next time, perhaps, Ricard?
I mean, I'm okay if people are okay to go till 10, 10, 10,
Okay,
15.
okay. So
Okay.
let's say if no one disagrees in the next 15 seconds, you can start.
Okay.
I didn't hear any disagreement. The 15 seconds are over now, so please go ahead.
Sure. Yeah. Thanks. Let me share my screen. I made some presentation. So the first I'll go with the overview of the feature. A few weeks back, I presented a proposal for flow exporter in Antrea agent. So it's like a short recap, and then we'll do the demo, and I'll talk about the future work that is yet to be done. So the basic the basic thing in this feature is we collect the connections in the contract table are exported by the Antrea agent as flow records. We use Ipv6 protocol to send it to a flow collector, and then the flow collector we provide visibility into the flows that are going that are present in each node in the Antrea cluster. For that, we built a connection store by polling contract module periodically, and then this we call it as poll interval. So every few seconds, we poll and build the connection, poll the contract module and build the connection store, and then at specific interval called as export interval, we convert these flows in connection store into flow records and send them to Ipv6 flow collector. And for that, we have written a Ipv6 library in Golang. It was not available, so we did it from scratch. And then that will be available as a VMware open source library at github.com. And if people are interested in to know more details about this feature, there is a URL and there's an issue in Antrea as well. So the flow records mainly contain the standard Ipv6 fields, which are like 5 tuple and some stats like packets, bytes, including reverse direction. In addition to that, we have Antrea specific fields like pod name space, node name, etc. for source and destination. And in this demo, we as a first phase of this feature, we resolve only local pods, pod names, pod namespaces, and local node names. This is essentially what I'm going to show today. Let me show you the flow collector dashboard. So this flow collector is basically based on ELK. It's not Elastiflow. EO had worked on it, and this is based on ELK stack, Logstash, Elasticsearch, and Kibana. We did not use Elastiflow as such. So and this flow collector is deployed as in the Antrea in the Kubernetes cluster, where we are collecting the flows, and it's running in the same cluster there. And so here, we can select the time interval to see number of flow records received. So in the last 15 minutes, let me refresh. We have received these 9 flows every minute. So our export interval is 60 seconds, and our poll interval is 5 seconds. We poll the contract module every 5 seconds, and then we export these flow records every 1 minute from the connection store. And I'm showing here, I have added a filter default. Our workloads are on default namespace. And so the source and destination pod namespaces are default. And we can see our workload has 9 flows flowing through. And in our cluster, there are 3 nodes: master node, worker node 1, and worker node 2. So these are the so this is one kind of a dashboard where we can see how many flow records we have received till now, and we can change the time. So to see like the history, like 3 days, 4 days, and like that. So and then the second dashboard we have is let me refresh again. We have is with the flows, and the left diagram is essentially the left side vertical line shows the source pod names and pod namespace, the default web client, etc. And then the right one shows the destination, pod namespace, and pod names. And the terabytes is basically cumulative sum of bytes that have been seen in the flow over last how many ever minutes we are going to select here, time. So here here as well, I have chosen the default. So and then the next the right diagram is for reverse bytes in that flow. This is in the forward direction, and this is the reverse direction. So, and we have considered 2 workloads for this demo. One workload is intra-node flows, and which is unidirectional. That means the client is sending data to server. And then the second workload is inter-node flows, where the client and server are sending data to each other. So the 2 workloads, and I'll focus on the first one, the intra node, which is the web client 1. Yeah, let me. It's web client 1, and the destination is also the web server. Yeah. So anyway, here there is only one intranode flow. The client is talking to server. These are Ipv flows, and we can see that there is a lot of data that has been sent from client to server, and very comparatively very less data received from server to client as acknowledgements. And we also here we also show the time series of the flow throughput. So here we have 4 graphs. This is for last 15 minutes, how many ever we are going to select. Here, the last 15 minutes, we can see the throughput of from the source pod TX Mbps, how much data the source pod is sending to a destination pod. And then source pod RX Mbps is how much data it's receiving from the destination pod in each flow record. And here you can see around 130 gigs per second is being sent. And then the reverse direction is only acknowledgement, which is around 136 mega bits per second. So, and this is kind of redundant. We kind of show the destination pod TX Mbps, which is like the RX of this one, and similarly destination pod RX is the source pod TX. So there are these 4 time series based plots. So this is intranode flow, and let me show the internode, which is a little more interesting than this scenario where the web client and destination is a web server. So the essentially what happens in internode flows are like each node will have a flow record for the same flow, right? And then, as I mentioned, as a first phase in this feature, we only resolve local pod and pod namespaces, and we don't resolve the remote pod and pod namespaces. So here, as you can see, let's say the web client is on worker node 1, and then web server is on worker node 2. So the here essentially, and I also mentioned bidirectional traffic. Here the client is sending data to the server. As we cannot resolve the remote pod, we show the IP here, and we can see some amount of data is going from the web client to this IP, and then you can see the IP of the web client is also here 10.0.2.60. So, and then the same flow will be there on the node 2 as well, I mean worker node 2. There we resolve the local pod name web server, and then we cannot resolve the remote pod name and namespace. And so essentially we have two flow records for the same flow. And the amount of bytes that are sent is almost the same. And then here there is bidirectional traffic. So we see the reverse direction, there is some data flowing as well. And we can see the same thing here in the time series, like the flow throughput representation. And the node traffic from is around 5 gigabits per second in one direction, and then 3 in the other direction. This is somewhat like we can in future we can probably think of some sort of since the flow records of the same flow are there, we have to aggregate them, or we have to do something for the internode traffic. So this is what we want to show in the demo. Any questions?
Hi, Shuraka, I have a question. Can you
Sure.
Can you repeat on why we couldn't resolve the IP if it's on another node?
Oh, we don't create watcher, so like we don't have the information in the Antrea agent. So we kind of rely on interface store that is there. Okay. Yeah, we don't. The plan is to do this through flow aggregator, send all the flow records to one guy in the cluster, and there we'll resolve the remote pod name and pod namespaces. That's the next phase. Yeah.
This week I have another question. So for elastic flows, do we need any customization of the elastic flow views to filter by the attributes we append to the flows, or elastic flow can support you to do filtering or search with any attributes?
I think we have to customize. I think you can add more, but she actually moved away from Elastiflow and used like her own Logstash and script, and then the Elasticsearch and Kibana, because there was some license issues to use the Elastiflow, put it in Antrea. So she went, and she can add more on that. Can you?
Yes, because of the license problem, we need to move to pure Elastic Stack, and the filter are all customized. It's not like customized. It's start from scratch, written by us.
So this one, then that is like the Kibana plugin, or how the code is like?
The Logstash will collect the data and do some processing, and then store it in the Elasticsearch The Kibana is only for the visualization. So we are using some built-in visualization of the Kibana.
Sorry, probably I didn't got that.
Uh-huh.
So how we insert our code to do this filtering and analysis into the stack?
It's like deploy some manifest in the cluster.
I see.
And then it will work as a data flow collector. And then we just need to send data to the service.
Okay, so you mean the service by ourselves? So we add some service code with Elasticsearch to consume the data and then present in the Kibana.
Yes.
Okay, I got it.
Yeah, like to give a specific example, for example, we calculate the throughput using octet delta count, and then we use the interval of the records received for each flow record, like the time space between those records. And we use that octet delta count and then interval, and then calculate the throughput.
Got it.
That's estimated. So that is added in logstash script, our code.
So you guys already create the PR for the code, or
yeah? I think Yo has a PR.
I see. Maybe I missed that one. I thought it's some testing code. Seems it's not.
Yeah.
Yeah. Did I hear you correctly? We can add additional pod metadata to the flows as well.
Yeah, this pod name and pod namespace, right?
What about labels?
And
can we do that as well?
Labels, yeah. If the information is available, we can send it as a record, as a field in the record. So we have to explore how to do it. But if the information is available, we can send it as part of a flow record. We can customize the fields in our Ipv6 flow record. We can add any number of our own fields.
When you say information is available, you mean in the agent or?
Yeah, like if it is available in the agent, we can add there itself. But if not, we have to do it at flow aggregator with the centralized guy, which we are planning to do as a next step in this implementation. I'm going to talk about that in future work. Okay, so let me talk about the future work. Essentially we are planning to add network policy rule info to the flows as the next step, and then also exploring with Antrea proxy. Looks like the service mapping info is available at the agent, so we want to add the service name and everything to the flow record. That's another thing, and then create some flow metrics out of this as a Prometheus metrics. These are the three things that are we are thinking, and then as I mentioned during the demo, a flow aggregator where flow records will be receiving from every agent in the cluster to this one guy, where we are going to have watchers, and then we can resolve the remote pod namespace, node names, etc. And then for kube proxy scenarios, we have to resolve the service information for each flow record. Essentially, the idea there is there are two contract flows, one with cluster IP and one with endpoint IP. So we have to send both the flows to the flow aggregator, and then based on the mapping between endpoint IP and the cluster IP, we have to correlate these two into one flow and flow record with the service names, etc. So that is the next with the flow aggregator. This is what we are planning to do. And then for that, we need a more Ipv6 implementation where we have to implement a Ipv6 mediator which can collect and add this information and then send it to collector again. So this is what we plan to do. Yeah. So that's it from my side. Any more questions?
So for the network policy rule flows, is it possible that you can have additional metadata to the flow? For example, I recently saw in some demo that a particular flow, let's say the default flow is being hit for traffic. We can tag it as like an unprotected flow, saying that this flow was not covered by any network policy, so it was not explicitly allowed, it was default allowed. So that way, with one view of the system, you can see how many unprotected flows are happening in the system, and that could give visibility.
Yeah.
Is that possible with what we have today?
I think I can answer that better once we implement this the network policy. The idea here is to use the connection label, and then if the connection label, when we are adding to contract contract module, through connection label we are going to send this network policy metadata or rule ID or UUID. We are not sure how it will be, but that's the high level idea. So let's say if the connection label is not there for a contract flow, that means it did not go through the network policy, right? So it is possible to do that kind of a thing. Until we implement this first part, I cannot tell for sure whether that can be done, but at least from the high level idea, yes, it's possible.
Thanks. Something to keep in mind.
Yeah, sure. I'll definitely.
Are flows are flows something that can be selectively enabled, or is it an all or nothing? You're looking at all flows or no flows.
Can you repeat the first part?
Are flows something that can be selectively enabled? Can I say that I only want to look at flows from a particular namespace or a particular set of pods with certain labels, or is it something that has to be all on or all off?
We can do that as part of visibility here through filters, but not at the Antrea agent. We get everything that is there in the contract module that is that is relevant to the Antrea, like all the flows. Yeah, we don't have any filtering at the agent itself, but we can do that filtering on the dashboard here.
Yeah, actually, I was also thinking it might be a valid requirement to do some filtering in the agent too. For some case, probably we don't want to monitor all the traffic, and then we can.
We are seeing, for example, there is Logstash and everything. Yeah, Kibana, right? So this may not be of importance. Yeah. So yeah, I think we can definitely explore that to have that sort of a filter, because contract definitely provides the filtering there. But the thing is it's easy to implement, not show certain things, right? Or rather than show only multiple things, you'll have multiple filters, right? So what I'm saying is negation of a filter is probably easier to implement rather than to say that I want to see only these 100 flows or something like that. I'll definitely add that as a point. What is the benefit that we are looking at is about the monitoring traffic or anything else?
So for the filtering is more about to reduce the traffic from
Okay.
agent to the connector.
Okay. Yeah. Monitoring. I can see.
In this case, how do we want to make it configurable? Like, how would the configuration happen for this filtering?
I think, yeah, probably Jianjun can add maybe ant control or something like that, because config map would be overloaded, right?
If you want to do some filtering, I think probably some CRD in my mind.
Okay.
I see. Yeah, I think we can think more about this.
Yeah.
Any final question on this topic? Perfect. And as we are already quite a bit over time, is there any final topic that we would like to quickly bring up for today? Waiting 10 seconds. All right. So I would like to thank Wenning, Janshan, and Srikar for their presentations and demo. We really appreciated this meeting, which is also been probably the longest meeting in the Antrea community history meeting. So we set a record today. So I am going to stop the recording now, and I wish everyone a good morning, good afternoon, good evening, or good night.